Oh, okay. In math's last episode, we ended up here. Now, what we're going to do at this point is we want to define what we mean by how this unit circle gets us to sine, cosine, and tangent. Or to put it another way, we're going to define the sine, the cosine, and the tangent, which are actually functions in terms of the values that we're seeing on unit circle. Now, I hope you've got a fully filled out unit circle in front of you, because that's going to be very helpful. Okay, now, so I'm going to take this away. Well, yeah. Okay, so you can see that each one of these points here are x and a y coordinate, but for the purposes of the function and for the definition that we're going to follow here, because these x and y are different than the x and the input and the output for the sine and the cosine and the tangent function, we're going to want x to be the input value of the sine, say, and we're going to want y to be whatever the output value is, right? That's normally how we think about how we designate the inputs and the outputs. So what I'm going to do is I'm going to call these, maybe light green up here, we're going to think of these as A and B. This unit circle x is going to be the A, and this unit circle y is going to be the B. Okay, so far so good? All right, now, so I'm going to get a blank sheet of paper over here. Here it is. What the sine function does, I'm going to put it right here. Okay. Here is how we define the sine function, which is S-I-N-E when you spell it out, or S-I-N is the abbreviation. Okay, is like this. It's y equals to sine theta, or y is equal to sine x if you want. Remember, theta is that weird Greek letter that's traditionally and by custom used in math and in science and a lot of other places to designate an angle when it's an input value. So sometimes without even really thinking about it, I'll say x or I'll say theta, but it's the same thing. It's the input. Now, here's the way the sine function works, right? Is you can see like any function, there's going to be an input and there's going to be an output. And this will work on our calculators too. What you should do, and maybe I should have told you this in the beginning. In fact, if you don't have it, you should put the video on pause right now. Get a calculator out in front of you, one of your scientific ones, and then make sure that the calculator is set on degrees for angles. It probably is for the factory default, but your calculator will also do radians as well. If in any of the stuff that follows, you're getting numbers that are weird and different than what I'm getting, it might be because your calculator is set on radians. Now, I'm not with you there to help you fix that, so you're going to have to figure out how to get your calculator, if it's not set on radians, to be set on radians, okay? All right. So, that means now on the calculator here, you're going to be able to see on mine, you're going to see, I'll zoom in down here for a second. Oopsie, there it is. You can see here's a sine button, a cosine button, and a tangent button. Those are the abbreviations, right? And so what happens with the calculator is, mine's set on degrees, I can type a number in. Let's say it's 30, okay? And then I can hit the sine button. Oopsie. No, see on mine, I've got to hit the sine button first. And I type 30. Yours, on your calculator, you may type the number first, then hit the sine button. Depends, okay? So I type sine 30. So what I'm doing is, that's the sine function, and I'm putting 30 into the function, just like this, okay? I'll zoom out a little bit, okay? I'm putting 30 into sine, so theta, that's the angle measure, and 30, like 30 degrees from our unit circle, that's the input. I hit equal to, and it tells us 1/2. Well, Or yours might say 0.5. Yours probably says 0.5. It's giving you the decimal version of it. Okay? Well, what it's doing is, here's 30 degrees on the unit circle. Let's zoom back out again. It's always awkward changing the focus on my camera here. Okay. All right. Good. I hope you can see that. All right. Now you can see here 30 degrees or pi over 6 in radians. Oh, look, that's the 1/2 number here. That was, we're going to call it the B number from the ordered pair, right? Now, if I do cosine 30. Oh, mine, which gives the rate, which gives fractions, that says rad 3 over 2. Yours probably says 0.866 repeating, which is the decimal version of rad 3 over 2. Try that. So yours might say 0.866 like that. That's the same thing as rad 3 over 2, right? Rad 3 over 2 is the exact value, which is what we're going to learn to write. Okay, so that's rad 3 over 2. Oh, look, that's the A coordinate, or the X coordinate for the unit circle coordinates, right? So here is the definition of sine and cosine. Okay, if you've got the unit circle, here's the picture, like this. All right. And we've got some angle theta, or x. And that angle theta is, remember, going to be associated with A comma B, the coordinates of the unit circle. Then sine theta is equal to whatever that B coordinate is. Cosine theta gives you the A coordinate. It's an alphabetical order. A comes before B, C comes before S, right? Cosine goes with A, sine goes with B. And it turns out that the tangent, abbreviated tan, is equal to whatever B divided by A is. It's the ratio of the two. Okay? Now, so that's how that goes. So, in other words, this is, so on this sine function, y equals sine theta. Theta is the input, the x. The y value, if your sine is B, if your cosine, the y value is the A coordinate from the unit circle. And if your tangent, the input is still whatever the angle measure is. The output is the ratio of B over A. It's how, by the way, on the right triangle trig ratios, the tangent becomes the sine divided by the cosine, right? Opposite over adjacent. Okay, anyway, so that's how they're defined. It's not like an algebraic y equals x squared plus 2 kind of pairing up. There's not an algebraic equation that tells you which x goes with which y. In the world of trig, the pairing of which x goes with which y is given by this rule right here and the corresponding values of the unit circle. So we're going to look at the unit circle. So that means let's go up to 60 degrees here. That's the cosine of 60. That's the sine. This is the cosine of 90. 1 is the sine. This is the cosine. This is there's 120. That's the cosine. Negative 1/2 is the cosine. Rad 3 over 2, or 0.866, that's the sine. Try it on Mr. Calculator. Okay? Hopefully you can see that. This is so you can kind of confirm for yourself. If I do cosine and then 60, 1/2, which is 1/2. If I do sine 60, rad 3/2, which you're probably seeing as 0.866. That's the sine value. Up here, if we do cosine 90, 0. That's 0. Sine 90, 1. There's the 1. If you do, on other parts of the unit circle here, if you do cosine 180, oops, there's your -1, and so on. You'll see down here, for instance, that 5 pi over 4, that's 225, right? That's these coordinates here. So if I do cosine 225, that's negative rad 2/2, which you're probably seeing as negative 0.707. That's rad 3/2 written out as a decimal. If I do sine 225, negative rad 2/2 again, because they're both the same, right? And so on. So you can kind of confirm these values all the way around. Now, if you're not getting these values, or at least the decimal version of them, when you type them into the calculator, it probably is because, well, maybe you're just not typing the numbers in wrong, right? Or it could be that you're set on radians. So it could be that your calculator is doing sine of 225 radians instead of 225 degrees, which is a completely different angle. Okay, so if you're not already, make sure you're set on degrees for the work that follows. Okay, all right, now we'll do a little bit with radians. A little bit with radians. Mostly we'll do this with degrees. This is going to be a big topic next year in pre-calc, in which you're going to spend a whole semester on it, right? But for now, we're just kind of getting our feet wet. So this is how sine, cosine, and tangent work. Okay, just like this. Okay, so now, I've already worked out here, on the table here, on our circle here, I've already got what the sine, what the cosine, and the sine are. It says right on the unit circle if you've got it filled out, right? For all of these angles, both in degree and in radian measure, we've already got the sine and the cosine values already written out, right? So, and for these familiar angles here. Now, of course, I could do like cosine 80, boom, it's 0.174 about, right? So in other words, in the cosine here, if I put 80 in for the angle, oopsie, here it is, 80 in for the angle in degrees, what comes out is 0.174. Okay? Now, hopefully that's okay. Hopefully we can get that, okay? All right, now, if not, well, I'll be on the video and we can ask questions about it. But this is super important to understand how trig works and everything that comes after this, to understand how the sine, the cosine, and the tangent functions are defined and how they relate to the unit circle. Okay? Now, so there's that. Okay, so now, what about tangent? Well, the tangent value, remember, is b over a. Okay? So, for instance, for 30 degrees, for pi over 6, I'll write it here. The cosine value is rad 3/2. So cosine 30 is rad 3/2. And sine 30 is 1/2, right? I'm going to move that up. So I just wanted to copy that in so we can see it. So what would tangent be? Well, remember, in terms of our definitions, that's the A number, that's the B number. So we put, to get the tangent of 30, we would put the a over the b, 1/2, divided by rad 3 over 2, right? Now, we're going to simplify that and rationalize it. So, because remember, this is b over a according to our definition here. Now, one way to see this is I'm just going to multiply by the reciprocal. Like that. Cancels out the denominator. And that's going to give us that it's all right, up here on the top, so that's 1/2 times 2 over rad 3, because the denominator canceled out because we multiplied by the reciprocal. Notice here that, oh look, the 2's cancel, cross cancel, and you see we end up with 1 over rad 3, which we rationalize as rad 3 over 3. Okay, so the tangent of 30 works out to be rad 3 over 3. The tangent of 60 is the other way around. For 60 degrees, b is rad 3 over 2, a is 1/2, right? And you can see it's simpler here. Those 2's can just cancel out on the bottom, and we've got rad 3 over 1 or rad 3. Okay? And now for tangent of 45, okay, at 45, the a and the b are the same. Tan 45 is rad 2 over 2, rad 2 over 2, and those both cancel out and we get 1. So I'll summarize it over here. Tan 30 is rad 3 over 3. Tan 45 is 1. Tan 60 is rad 3. Okay, now, so we're going to fill those out on our charts here. I'm going to use, well, let's see, what color have I not used yet? I'll use hot pink. Okay, so hot pink will be the tangent values, which are b over a. So this is, remember, this is sine, this is cosine, and the tangent value is going to be, this one is going to be rad 3. This one is going to be 1, and this one is rad 3 over 3. Did I write? Yeah, that's right. So rad 3 over 3, and 1. We can try that out on Mr. Calculator, right? So, tan button, which is right here, tan 45 equal to 1. Okay? Tan 30 tan 30 is equal to, as it says here, rad 3 over 3, which in decimal form is about 0.577, right? And then tan 60 in decimal form is about 1.73. Okay, but just to make it, and they're infinite decimals, they're irrational numbers, they're infinite, they keep going, so the easiest way to write them is in terms of these radical numbers here. So using the same symmetry, by the way, that we did for the sine and the cosine coordinates, okay, this tangent is also rad 3. I'm sorry, negative rad 3, because it's negative divided by positive. This one is negative 1, because it's negative divided by positive. This one is negative rad 3 over 3, because it's negative divided by positive. Now, notice we skipped over 90 degrees. We'll come back to those in a minute. Down here, this one is it's going to be negative divided by negative, which is positive, so it's positive rad 3 over 3. Negative divided by negative is positive. Negative divided by negative is positive rad 3. Notice again, the coordinate values are, the function values are the same. Just the only thing that's different, they're the same as the values in the first quadrant here. The only thing different is they're either negative or positive, depending on what quadrant they're in. Okay? This one has got to be negative rad 3, because it's negative. This was negative divided by positive divided by negative. This one is negative divided by positive. So these will all come out to be negative again. So those are the tangent values. So what we've got here are the sine, the cosine, and the tangent values for each of our important sort of evenly numbered unit circle values, right? Okay? And we've defined them here, okay, as to how much they're equal to, okay, as to which angle goes with which, and you see there's a degree measure and an angle measure associated with a cosine value, a sine value, and a tangent value, right? And they're also, your calculator knows what they are too. But this is why your calculator knows, is because of this unit circle here. All right, now, so here is our definition here. Now the last thing I want to is going to be your homework here. And what you've got, I'm going to have uploaded here a blank, it says circular function chart. Now over here, it gives the angles in radians, right? So the first thing you're going to do, that's n, that's the angle measure. Let's call that theta. It says n, but it could be theta, theta, theta. It says x and y, but that's really going to be a and b, right? Those are the points from the circle. So what you're going to do here on this chart, first off, is write in from the unit circle what all of the corresponding degree measures are. And I'll get you started. That's 0 degrees. That's, oopsie, that was right. That's this angle here. We haven't gone anywhere. We didn't rotate at all, so it's 0 degrees. Pi over 6 is 30 degrees. Pi over 4 is 45. Pi over 6, 30. Pi over 4, 45. Pi over 3, 60. So I'm going to number those all the way down here. Okay, this is 30, 60, 30, 45, 60. Pi over 2, that was 90. This is 120. So we're just, as we go down the column here, you understand, we're going around the circle like this. You should see that this one is 270, right? And I'll just give you a random one down here. This one is 300, oopsie, sorry, those are in the wrong place. Those are in the wrong place. I apologize. That's where we're putting the A and the B values. Now I can't find my whiteout that I was using. Okay, so I'll just be messy and scratch that out. Okay, 270 goes here. 315 goes here, right? And then so on, right? So you're going to put, along with the radian, in the N, which is the theta column, you're going to put the angle measure. Then over here, you're going to put the coordinates, A and B, the unit circle coordinates, which we're labeling A and B. So this one is rad 3 over 2, 1/2. No, it's not. Wow. Sorry, my eye skipped ahead. This one was 0 degrees. That's 1, 0. This was rad 3 over 2, 1/2. This was rad 2 over 2, rad 2 over 2. This was 1/2 rad 3 over 2. And this was 0, 1. So those are the unit circle, the A and the B coordinates from the unit circle. Then here, you're going to fill in the table. Now I want you to notice that it's backwards. That's the sine, that's the cosine. Now our table here uses n as the input value instead of x or theta, but it doesn't matter. It's just a label for a value. N is the input. We're calling it theta. So we're looking here, what's the sine of 0? Well, it's the second number here. The sine at 0 degrees is 0. The cosine is the first number, a, and that's 1. And then the tangent is, remember, we didn't fill all these out, did we? Okay. The tangent is the sine divided by the cosine a over b. So this is 0 over 1, which is equal to 0, right? So the tangent there is 0. Now, so that's going to be, so this tangent over here is going to be 0, because it's this number divided by that number. Okay, here, the cosine was, or the sine was 1/2. Remember, it's the second number. The cosine is rad 3 over 2. And when we calculated this, that worked out to be rad 3 over 3. So that's the tangent. And then this was rad 2 over 2. And this is rad 2 over 2, right? And then that was equal to 1. When we calculated it, right? I just threw it down somewhere. Okay. Wow. Okay, let me straighten this out. Okay. This was rad 3 over 2. Keep in mind, it's backwards. It's a sine value on this chart they're putting first, and then the cosine. So it's rad 3 over 2, and then 1/2 for the cosine, and we decided that was rad 3, right? Okay. Now, and then for most of these, you just fill in the hot pink values that I put in here for the tangent. That was go into the tangent column here. Now at 90 degrees, we didn't do that one, right? Because at 90 degrees, we said the sine was 1, right? And the cosine, of course, is 0. And so this 90 degrees, the tangent is supposed to be b over a. It's supposed to be the sine divided by the cosine. Well, that's 1 over 0, which, of course, is not a number. So try that on your calculator here. Do tan 90, and it will give you some kind of an error message depending on your calculator. The tangent function is undefined at 90 degrees. So I'm just going to write undefined there. Now there's one other spot where it's undefined, where the cosine value is 0. Guys get that? So your homework is going to be, and somewhere else on this chart, there's one other spot where it's also undefined. Now what I want you to do, here's your homework, is you're going to fill in the rest of this chart here using the values that we've got here from the unit circle. That's all your homework is going to be. Alrighty? Okay, very good. So the rest of the angles, the ordered pairs here from the unit circle, like this, right? Which I filled in some of them down here that fill in this chart, and that's going to be your homework. Okay, very good. All right, so thank you, and talk to you later. Bye.